Hey guys, in this video we're going to be taking a look at theorems about proportionality, and basically that's looking at triangles and rules that go with them and all the different ways that you can solve for certain sides using a proportion to solve. So the first one that we have is the triangle proportionality theorem, and what that says is if you have a line parallel to one side of a triangle and it intersects the other two sides, then it divides the sides proportionally. So basically, if you've got a side DE and it's parallel to BC, and we know that they are because of those little triangles, then we know for sure that AD over DE is going to be proportional to AE over EC. And just like before with our similarity rules, we're matching up same part over same part. So AD matches up with DB. So AD matches up with, ooh, I miswrote that, DB. And AE matches up with EC. They're matching up just like that. There's lots of different ways you can write these. You're going to get problems where you're matching up just the bits and pieces, and whatever is on above that parallel line stays above the fraction, and whatever's between those two parallel lines stays underneath the fractions. You just have to be consistent. If you start with the top and then go down the side, you got to stay with the top and then go down the side. There's another way that you can write the proportions. You can do it as just the little part right here in purple, or just the little part right here in pink, and then do the whole big side. And if you compare the whole big side on one side, you've got to compare the whole big side on another. So you can go, or you can go AB over AD equal to, see how I did AB the whole big side? That can be AC over, and I did the top here, so I've got to do the top over there, AE. So AD, AE. Or you can go the whole big side and just the little part right here. So you can have AB over DB equal to AC over EC. It's just whatever you need to solve for in the problem. Any of these will work. And honestly, there's a lot more that you could use. You just have to make sure that you're comparing the same part of the triangle with the same part in the triangle. So if you're comparing the big side on the left, you've got to compare the big side on the right. And if you're going to do the little sides there, it's got to be both of them there and both of them there. You've got to keep everything straight. Okay? So that's one way. If you're given two parallel lines within a triangle, then you can do these ratios. Conversely, remember converse in geometry means, or you could do the opposite. If you're able to show that you can write a proportion that's true, then you can say that the two lines are parallel. So a question that you could be given is, given this picture here, is DE parallel to CB? And just with that question, you would have to know, well, if these two are parallel, then those will be proportional. So then you would have to go, okay, well, I've got to check AD over DC, and then AE over EB. So you would have to show that that statement's true. And notice I did AD on top, AE on top, AD, AE, and then DC and EB there on the bottom. So if we try that out, we're looking at 18 over 6 is going to be equal to 24 over 8. And if you simplify 18 over 6, that's going to be 3 equal to 24 over 8 is 3. So we've created a true proportion. So because of that, we are able to say that DE is going to be parallel to CB. And this could come up in proofs that they do for the state test. But for what you need to know for what we're doing for our class is just to be able to use these to solve problems is the big deal. Looking at the triangle mid-segment theorem, looking at the word mid-segment, that means it's going to cut the segment in two. Or you could also look at it as the point is the midpoint for the line or the side. So the mid-segment of a triangle, and so if you're looking here, this point right there, E is going to be the mid-segment for AC, and DE is the mid-segment for AB, means it cuts it into two equal parts. And if you look at the picture, this part is equal to that part, but they're not necessarily equal between each other. They just have to be equal on the line that they're on. So we're looking at the mid-segment of a triangle is parallel to the third side of the triangle and half the measure of the third side of the triangle. Okay, so what they're saying is DE is equal to 1/2 of BC. That's what the definition says. What I will have you guys do is I will say, well, BC is equal to twice of DE. It's a lot easier mathematically to work with the 2 and multiply the 2 than having to worry about the 1/2. So what that is saying is, if this is 7, if DE is 7, you multiply whatever this number is by 2 to get the length of this one, so 14. So there's your one example. And if I give you another example, let's say this is 42. So ignoring that the 7 and 14 are there. So if this one's 42, this one right here is going to be half of 42, which is 21. Okay, so whenever you're going from here to there, you multiply by 2. Whenever you go from there to there, you divide by 2. And then the last one we have is the angle bisector proportional side theorem. And with that, we're looking at a bisector of an angle. So there's the angle right there. And then it's going right through there. And we know it bisects it because it cuts it into two equal parts there. Now what I'm going to tell you is the mistake that people always make with this problem is that they assume these two are equal. They are not equal. They can be, but the majority of the time they are not going to be equal. So keep an eye out for that. So if we have a bisector of a triangle, it's going to divide the opposite side into two segments whose lengths are the same ratio as the lengths of the side adjacent to the angle. So pretty much when you're solving triangles like this, you have to have an angle bisector. Then you can do A over C is equal to B over D and solve that way. So if we start trying these out, the first ones we're going to try out are this triangle proportionality theorem and its converse and using that. So this whole page that we're looking at right here is going to be your triangle proportionality theorem. And I'm going to put in parentheses that it's also going to cover the converse. So this is how they use them in problems to solve. Alrighty, so looking at this one, it says find UW. So if we find UW, UW is this whole big thing right here. And whenever we talked about it in the definition, we said if we're going to compare the whole big side on one side, it's got to be compared to the whole big side on the other. If we look, we don't have that here. So we can either create it by doing this whole big side here, or we could just do it the little parts. I'm going to do this one with just doing the little parts. So in order to know what this big side UW is, we would have to know what this little side VW is. And we don't know what it is. So I'm going to represent it with the letter X. You could also just leave it VW. I think I'll go ahead and leave it VW and show you how that works out. And then you can replace it with X whenever you do the problems if you like. So if we set up a proportion, it's basically the top values in the top of the fraction, the bottom values in the bottom of the fraction. So if we're looking, and as far as top bottom is concerned, whatever's in the top in the picture is the top. Whatever's in the bottom is in the bottom. You don't have to take this and flip it over just to be able to solve. So this is 13. I'm going to do the names. We'll do UV over VW is going to be equal to, well, we did UV here, so we'll do TX there over XW here. So UV has a value of 13 over that part we don't know, so I'm just going to leave it VW is going to be equal to TX, which is 11, over XW, which is 22. So this is a proportion. So to solve a proportion, you just cross multiply and divide. So to do that, you've got 13 times 22 is equal to 11 times VW. And yes, I want you to write these steps out and show them, because you're going to get to problems that are harder where you're going to have to write it out. And if you don't practice with the easier problems, you're going to be trying to figure out the harder stuff at the same time you're trying to figure out this stuff. So it'll make it easier on yourself in the long run if you go ahead and get this practiced. So we do 13 times 22 gives us 286 is equal to 11 VW. We want to know, right now we're solving for VW, so divide both sides by 11. So 286 divided by 11, VW is equal to 26. So if I put that on in the picture, there's the 26 there. But you got to be careful, because the problems will jump around and ask for different things. Just because you solve for a number doesn't mean that's what you're looking for. We want the whole thing. So in order to get the whole big thing, it's that part plus part is equal to total again. So 26 plus 13 is going to give us the whole big thing, which is 39. So UW is equal to 39. Looking at the next one, for the next one, they're asking us to find FG. So FG is right here. It's just this little one right here. So if we need to solve for that part, we would be comparing this top part to the bottom part. Well, if we look, we've got a top part there, but we don't have a top part here. We could do this whole big 57, but we don't have a whole big side down here to add it to, and the math would be a lot more work than it would need to be. You can do it that way, but it's going to be a little more work. So what we can do is we can take 57 and subtract 19 from it and get IJ right there. So do 57 minus 19 gives us 38. So now we can set up our proportion to solve, because we can do this part compared to that part, and then that part compared to that part. So we've got JI is equal to JF, and then we started here with this line, so that needs to stay over on the left with the other parts of it. So we've got HI over FG. JI has a value of 38 over HI, which is 19, is going to be equal to JF, which is 26, over FG, which we don't know, so we'll leave it FG. So then we cross multiply, divide. 19 times 26 is going to give us, so 38 times FG. 19 times 26 is 494. Is going to be equal to 38 FG. Divide both sides by 38. And that's going to give us FG is equal to 13. So that side's 13. And just to double check, I'm going to go up here and see what they're asking us to solve for. And it is 13, so we're doing just fine. Looking at the next type we have to solve. So looking at this one, they give us a whole big side on the top and a whole big side on the bottom, and we're looking for this little side right here. So we're going to be able to compare whole big side to whole big side, but the only part that they give us here is VW, and the only part that we can compare VW to is to TU down here. So I'm going to compare SV, and I'm using these right here, these two, where I'm comparing the whole big part to a little one, so a whole big part compared to a little one. So I'm going to compare SV to WV is going to be equal to SU over TU. And again, I'm using this WV right here and this TU right here because WV is the part that they give us to work with. So SV has a value of 45 over WV is 30 is going to be equal to SU is 24 over TU is one we don't know and that we're solving for. So if we cross multiply, we've got 45 times TU is going to be equal to 24 times 30. So 45 TU is going to be equal to 24 times 30 is going to be 720 divided by 45. And then TU is going to be equal to 16. So that tells us that this part right here is 16. But if we remember, they wanted us to find ST. So the way we get ST is to do 24 minus 16. So the whole total thing minus the part we don't want. And that's going to give us 8. There is another way that we could have solved this. And if we solve it the other way, we could have looked at this and said, okay, I want to compare this part to this part and that part to that part. Then we could have gone 45 minus 30 to give us 15 here. And then we could have gone VW over WS is going to be equal to TU over ST. And then VW has a value of 30 over 15 is going to be equal to 16 over ST is the one we don't know. So cross multiply, do 15 times 16 is equal to 30 times ST. So multiplying 15 times 16, 30 times ST. 15 times 16 is 240 is equal to 30 ST. Divide both sides by 30. And we get ST is equal to 8. And it doesn't matter which way you see to solve it as long as you're ending up at ST is 8. Looking at this last one over here, this is the one where I was talking about. It's going to be really important to setting up these proportions and then being very careful with your cross multiply to keep everything straight to solve for it, because otherwise things are going to get really messy. So we'll go IJ compared to JF, and that's going to be equal to IH compared to HG. So IJ has a value of 2Q minus 18 over FJ or JF is 2Q minus 14 is going to be equal to IH, which is 5, over HG, which is 10. So now we cross multiply. So 10 times 2Q minus 18 is going to be equal to 5 times 2Q minus 14. So we distribute. Now at this point it just becomes algebra from here to solve for. So 20Q minus 180 is going to be equal to 10Q minus 5 times 14. is 70. So I'm going to subtract a 10q from both sides. And 10q minus 180 is going to be equal to negative 70. Add the 180 to both sides. And 10q is going to be equal to 10. Oh, add 180. So then negative 70 plus 180 is going to be 110. Divide both sides by 10. And then q is going to be equal to 11. And I'm going back and double checking. Did it want us to find q? Yep. And q is 11. So those are some really good examples of what you're looking at whenever you're looking at the triangle proportionality theorem. And with these, something to keep an eye out for that I didn't talk about a whole bunch, as remember we talked about how the lines have to be parallel, or you've got to be told that the lines are parallel. So either by the little arrows in the pictures, or by being told that they're parallel in order to be able to use this rule and have it work. Otherwise, they're going to be asking you, are these lines parallel, yes or no? So that covers the triangle proportionality theorem. The next one that we're going to be looking at is this middle one called the triangle mid-segment theorem. And if you remember when we did the definition, the triangle mid-segment theorem says that this one right here, is going to be, this one right here is going to be half of that one. Or the way that I say to do it, this one times 2 is going to give you that one. So if we look at that and see how that works, Vx is 43. So if we look at this one compared to that one's going to be bigger. So people always have trouble remembering, well, which one do I do when? Well, this is 43. That one's the smaller one. So this one's going to be bigger. So you do 43 times 2 gives you 86. So TU is going to be equal to 86. And with these, the way that you know you're going to use the triangle mid-segment theorem is they'll tell you the line that you see in the middle of the triangle, it is a mid-segment. So that's a real nice obvious one. The other way that they'll show you that's not quite so obvious is that they'll put the tick marks. And these the two tick marks on one side will be the same. So looking from Y to X, 2 tick marks, X to W, 2 tick marks, which means this point right here is in the middle. And then looking here, this one has 1, that one has 1. So that tells you that V is the midpoint for UW, which makes this be a mid-segment. So that's how you know that this one is half of the big one. Okay, so with this one, we're looking at UY is 38, and they want to know what VX is. So 38, this one's the bigger one, so it's got to be, this one has to go smaller, so you divide this one by 2. 38 divided by 2 is going to be 19. So Vx or xw is going to be equal to 19. So those aren't too bad. Most people don't have too many problems with doing those types because they're very straightforward. It becomes a little bit trickier, and these are the types that they love to put on tests because it really checks to make sure if you're doing the problems right and using the rule right, are the ones where they're given variables. So what I like to do for these is I like to write the rule. So that I know SR, the whole big one, is going to be equal to 2 times the shorter one. So once you write the rules, see, I didn't even worry about what was going on there. I looked enough to know that I had midpoints here, which made this be the mid-segment. And then I just wrote the rule, and then from here, I'm going to go through and fill in the values and then do the algebra to solve. So it says that RS, and SR is the same thing as RS, is Y plus 76 is the value for RS. So that's where I'm getting that. So RS is that, RS is there. So there's that and that value right there. And then TQ is going to be that value right there and that value right there. And in order to be able to get this one, we have to multiply this one by 2. So 2 times y plus 32 will give us the value for y when we solve. So this part right here, you've got to know and be able to use the rule. Once you get the values in, you're doing algebra from there. So y plus 76 is going to be equal to 2y plus 64. Subtract y from both sides. 76 is going to be equal to y plus 64. Subtract 64 from both sides. Y is going to be equal to 12. And going up and double checking what they're wanting us to solve for, they want us to solve for y, and y is 12. So that one's done. Okay. Looking at the next one, I'm double checking to make sure I really do have a mid-segment. G is the midpoint because those two have 2 hash marks. I is the midpoint because those both have 1. So this is a mid-segment, so we can use our mid-segment theorem. And what our mid-segment theorem tells us is that Kj, the big long one, is going to be equal to 2 times the mid-segment, the one in the middle. So now to go look at the values, Jk or Kj is going to be equal to 4s minus 54 is going to be equal to 2 times Gi in this case is s. So 4s minus 54 is equal to 2s. Now we're just doing algebra to solve for s. So subtract 4s from both sides. And then negative 54 is going to be equal to negative 2s. So take 54, divide it by 2, and then s is going to be equal to 27. So to go back and look to see what we're solving for, it says what is jk. It doesn't say what's s, it says what is jk. And jk is equal to 4 times, now we know s is 27, minus 54. So jk is going to be equal to 4 times 27 is 108, minus 54. So jk is going to be equal to 54. So there's us that one. So that's going to be our triangle mid-segment theorem. And then the last one we have to look at is the angle bisector proportional side theorem. And they did have to go with both names because there is a separate angle bisector theorem that does something different than what this proportional side theorem will do. So what that tells us is that the left side over the left is going to be equal to the right side over the right. So for looking at this one, it says calculate the length for the indicated segment for each figure. So and they have to tell you that you've got an angle bisector. So CD bisects angle C. So that means this angle right here, ACD, is going to be equal to that angle right there, BCD. And it just says solve for AC. So here's AC, the one we don't know, and it's going to be left side over left side, right side over right side. So AD over AC is going to be equal to DB over BC. So AD has a value of 9 over AC, which we don't know, is going to be equal to DB, which is 11, over BC, which is 22. We cross multiply. 9 times 22 is going to be equal to 11 times AC. 9 times 22 is 198 is equal to 11 AC. Divide both sides by 11. And that's going to give you AC is going to be equal to 18. So AC is 18. And then looking at the last one, they tell us that segment BD bisects angle B. So if it bisects it, it cuts it into 2 equal parts. So ABD is going to be equal to angle CBD. And remember whenever I talked to you in the theorem and told you these two are not going to be equal to each other? And you can see how in the example that they weren't. And you'll see how in this one they're not equal to each other either. So if we're doing these, just like we did left side over left side, we're going to do this top triangle over the bottom triangle. And we're going, oh, it wants us to solve for AC. But in order to know what AC is, we have to know what that little part is right there. Okay, so we're doing this top side over top side, so AB over AD is going to be equal to BC over CB, CD. So AB has a value of 14 over AD has a value of 6 is going to be equal to 16 over CD. So we cross multiply. 6 times 16 is going to be equal to 14 times CD. 6 times 16 is going to be 96 is equal to 14 CD. Divide both sides by 14. And you should end up with a decimal. So you should end up with 6.8. We'll go 6 is equal to CD. So I'm going to put 96 over 14 just so that we have the whole value instead of the part. Or you could just take this right here, and while you have the answer in your calculator looking just like that, without hitting anything else, just go ahead and hit plus 6 to add in that whole part to get AC. And that'll give you AC is equal to 12.86. Okay, so there's your two examples for the, let's write the title above it, the angle bisector, proportional side theorem, and then these four middle ones right here are the triangle mid-segment theorem, where if you've got a mid-segment, how to solve for those. And then if you have parallel lines, the triangle proportionality theorem and its converse, and how to solve those. If you have any questions, be sure to write them down on your guided notes and ask whenever you get to class.